So we're getting started now with section 1.1, which is rational numbers. Okay, rational numbers are a category of numbers. We're going to talk about it here in the third definition, but basically these are numbers that have decimal values or fractions. Okay, that's what we would consider a rational number. Right? Then we have what are called integers. You guys remember integers from 6th grade? All right, those are positive and negative numbers that don't have decimal or fraction values. Okay? All right, so go ahead and start filling in the blanks. I know that these definitions are in your notes. I need you to go ahead and start filling in the blanks, and then we're going to go back and talk about the definitions here because it's really important that we kind of differentiate. Okay, so integers are not fractions or decimals. Is that kind of clear enough? All right, so they are what we call, well, we're going to say whole numbers even though that's not technically correct. So an integer, can anybody just give me an example of an integer? Does not have a decimal value attached to it. So we want to start with Joel? Negative 1, okay. Didn't have a decimal value. What's another example of an integer, Mr. Haynes? 24. Okay. Hadley? Negative 48. All right, so all these numbers have something in common. They don't have decimal values and they're not fractions. Those are integers. They can be positive or negative. Now let's talk about whole numbers. Do not confuse whole numbers with integers, okay? So you can almost bank on it to be like a true-false question at some point. Whole numbers are only positive. Okay, so they still don't have a decimal value, clearly. They're a whole number, but they can only be positive. In order for something to be whole, it has to be positive. All right, so 4, 62, 123, but it's never negative. All right, so just some random examples. You could write down different examples there. All right, so, and then that brings us to rational numbers. For this section, we're focusing on rational numbers being terminating decimals. Okay, you're going to see terminating decimals, and you're also going to see them written as fractions, and that's where you see this fancy A over B form. What does that mean? It's written as a fraction. Don't you love it when they make something kind of sound complicated? All right. Mom, did you know that A over B form is the same thing as a fraction? Okay, it makes you sound a little bit more fancy, right? Okay, just simply put, fraction. And then last but not least is absolute value. And we're going to spend the majority of our lesson today talking about absolute value, okay? The absolute value of a number is how many units it is from what? Zero. Zero is our baseline, okay? That's always our starting point. So how far is it from 0? Is it left 3 units? That would make it negative. Is it right 5 units? That would make it positive. But all we're looking, it would just be 3 or 5. We're just looking at how many units it is away from 0. It is not positive or negative. All right, and do you guys see these bars there around the X? You're going to see that pop up in your classwork problems and in our examples today. Anytime we see those bars, that means take the absolute value first before you evaluate, okay? And we'll be looking at that. All right, everybody good on our fill in the blank, our terms? Okay, so let's look at example 1. In example 1, all we're doing is finding the absolute value. And remember, it's not positive, it's not negative. It's how many units it is away from 0. So the absolute value of negative 3 is just 3. So you would box in a 3, all right? So you're going to write this, whatever I'm writing up here on the screen, that's what you'll be writing in your fill in the blank notes. Okay, the same rule applies for decimal values. Okay, so technically 5.3 is a rational number because it's a decimal value and it terminates, it ends. Okay, but going back to absolute value, I'm just going to write 5.3 without a sign. There is no sign, it's just 5.3. Okay, so let's come over here to the fractions. If it starts as a fraction, go ahead and just keep it a fraction. Again, absolute value, I'm just looking at the value of the number 1 1/4. All right, and I'm going to throw in something to the last one. I'm going to throw this in out in front. So go ahead and write that into your notes. That's another negative out in front. All right, so can someone raise your hand and tell me what would be the absolute value of negative 5/3? We'll deal with the one out front in a minute. What's the absolute value of negative 5/3? Yes. Okay, just keep it in proper. Okay, we could just say 5/3, right? So typically this would be our answer, but because there was another negative out front, we're going to bring that one over into our answer. Do you see what we did there? So the negative inside the absolute value was evaluated, but because there was another one out front, we're going to bring that one over into our answer to make it negative 5/3. All right, I threw that one in there because in the next slide, you're going to see some of that. And now you'll know what to do. Everybody good? Any questions? Doing okay so far? All right, we'll keep moving. Okay, so now we need to compare numbers in absolute value. What's important here is I'm not just going to look at it and say, okay, this is greater than or less than, or try to answer it here. I need to first evaluate the absolute value because that's going to affect my answer. So what is the absolute value of negative 2.5? Just tell me. 2.5. Okay, so that's what I want you to write in your notes. There's a little bit of work there to show. And now I don't want to compare a decimal to a fraction. It can get confusing if I'm comparing in different forms. So can I change 3/2 to a decimal? Could I do that? Now, if you're a little confused, you're like, I'm not really sure what that's going to be. I would challenge you to first convert it to a mixed number, 1 1/2, and then it's a little easier to see. How could I write 1/2 as a decimal? Just tell me. 1.5. Okay. Now I can clearly make my comparison. 2.5 is what compared to 1.5? Greater than. And the greater than sign is open towards the 2.5. And then I would box that in. All right. I want you to work on the other three on your own. Once you're done, go ahead and compare with the person sitting next to you. I'm just going to do a quick walk around and check on you guys, and then we'll keep going. Okay, so let's look at the next one down. We see that what we call like a double negative kind of popping up again, so we need to be careful of that. All right, so we're comparing 7 to, what's the absolute value of negative 4.5? Well, just 4.5, but then you're right, I need to bring down the negative. Did you guys get that? All right, so now clearly which one is bigger? 7. So the greater than sign goes in the blank. All right, and then on the next one, 9. What's the absolute value of negative 9? 9. So what belongs in the blank? Equals. All right, and then on the last one, we have negative 1/2 compared to 1/4. All right, so just because of the value of a sign, we know that any negative number is going to be less than a positive number, right? So we really don't have to do any other work. However, I'm going to kind of caution you on this. If 1/2 had been positive, right, so that was the answer. But if it had been positive, okay, it makes the comparison a little more complicated. All right, so how many of you would say, yeah, I mean, I know 1/4 is less than 1/2. Probably a lot of you know that, right? But what if it's a little more difficult? You technically cannot compare fractions, whoops, wrong button, fractions with different denominators. You would have to find an LCD, okay? Not for this lesson, but in the future, we can't compare fractions of different sizes. Again, because 1/2 is negative, it's a no-brainer. We know it's less than. All right, so I'm not really worried about you showing that work on this assignment, but that's kind of what's coming, all right, in the future. We good? All right, good for now? Okay, so we're through example 2. Was that too painful? Was it not too bad? Okay. All right, example 3. I can't promise that I'm going to pronounce these volcanoes correctly. I almost just renamed them something that I could pronounce, but then I felt guilty because that's not what's in the book. So here we go. All right, you can watch the YouTube video back and laugh at me. Just don't laugh at me right now. All right, so it says the summit elevation of a volcano is the elevation of the top of the volcano relative to sea level. Can anybody tell me what sea level means in real life? Yes? Yeah, sort of, Joel.
Water level?
Yeah, water level, or I would just call it ground zero. Okay, so sea level is like, again, our starting point. It's just kind of ground zero. Anything above sea level is above ground. Anything below sea level is, give me one guess, underground. Okay, all right, so the summit elevation of, I think last hour we agreed that we were going to pronounce it Kilauea. Sounds good to me. Kilauea, a volcano in Hawaii, is 1,277 meters. The summit elevation of Lohi, an underwater volcano in Hawaii, is negative 969 meters. Which summit is higher and which summit is closer to sea level? Now, we might be able to answer this question without showing any work, but I want to give you guys a visual on what we call a vertical number line. This can be helpful, especially when you're unsure about something. So I want you to take these notes right there next to the think, pair, share. You've got kind of like a blank spot underneath example 3. I want you to draw this vertical number line. All right, and on this vertical number line, we're going to put these values. All right, does anybody know what, or have a guess as to what we would put for like our starting point? 0, right? And what do we call 0 in this example? Sea level. So we're going to label it sea level. All right. And what value do you think we're going to put above 0 on the vertical number line? Yes, 1,277. And that was Mount Kilauea. Kilauea? Maybe it's Kilauea. That sounds good. Koala. Okay. I almost tried to talk in an Australian accent, but I made the better judgment call and didn't because it would not have been good. All right, which one goes below? Which value would go below?
Negative 969.
Very good. Negative 969. And that one is Lohi. That reminds me of Loki from Thor. I don't know why. Anybody else? Come on. It's pretty close. Okay, so now we kind of have this visual. Why do you think we did a vertical number line?
Because
It's elevations, right? It's elevations. Okay, so now we have a visual on it. Now let's just answer the questions. Which summit is higher? And I know I misspelled summit. Did anybody else catch that? Then I misspelled it?
Yeah.
Oh, good. So I just told on myself. Yeah. Sorry, there's a typo. Which one is higher? Not a trick question. Which one's higher? You just tell me. Kilauea. Okay, Kilauea. What did I decide? Oh, yeah, Kilauea. Kilauea. I just need to stop. Okay. Kilauea. All right, just answer the question. And which one is closer to sea level? Lohi. Okay. All right, and that answers my question. Now, it's no secret that we are a little behind on our lesson plans due to the unexpected loss of school days. So I know I had this like really awesome think, pair, share assignment at the bottom of this section, and it is really awesome. So if you want to try that in your spare time, you can. But I'd like to go ahead and start on homework just because it's Friday. This lesson was supposed to be on Tuesday, and it would have been a different scenario. We would have done everything, but because it's Friday, I want to be mindful of the fact that we're coming up on the weekend. I want to go ahead and start on homework. So that will wrap up everything you need to know for section 1.1, and we can get started on our homework assignment.